Module Cheat. This project is the perfect emulation setup to study and develop the Linux kernel, kernel modules, as well as x86 and ARM assembly. One major feature of this project is that everything is built from source. This means that you can inspect and GDB step debug everything to perfectly understand how your system is working. To get started, you can check out the quick start instructions right here on the README. First, let's clone the repository. You don't need to do a recursive clone. Let's go into it. Make sure Docker is installed. I already have it. Let's set up the Python virtual environment. Activate it. Now we run some basic setup. The next step is to make sure that we are running on Ubuntu 20.04. This is because the build root build only works on that version. In my case, I'm running on Ubuntu already, so I'm just going to use Docker. But if you are running on Windows or macOS, you could just use a virtual machine for Ubuntu 20.04. To do that, I'm going to create my Docker container with this little helper. And then I'm going to go into it. Let's just check that we are on Ubuntu 20.04. And now we're ready to build. So this command here will download and build everything that we need, including QEMU, Linux kernel, and all the userland. So because it builds so much, it will take a few minutes. Once the build has finished, we're now ready to run the simulation. The run command boots Linux inside of QEMU. We are now left inside the userland shell inside the emulator, and we can run regular userland commands like ls and pwd. These are provided by the build root userland package. We can also try to insmod our test kernel module hello.ko. And we see that it was successfully insmodded. Now let's quit the simulation with Ctrl A followed by X. Because everything was built from source, it is very easy to modify any part of our system. For example, let's try and add a hello message to the Linux kernel boot. So we're searching for the start kernel function, which is a bit like the main. And then let's add a print k saying hello Linux Kernel Module Cheat. Let's save and exit. Then we'll build Linux again. And now let's run the simulation again. And here we can see there is our little test message, hello Linux Kernel Module Cheat. Because we have the source code available, one thing we can do is GDB step debug pretty much anything. So let's try and GDB step debug the Linux kernel. First, let's open a new terminal window and let's go inside Docker there as well. Back to the first terminal, let's run, but with the GDB waits flag added. So this makes QEMU wait for GDB to connect before running the simulation. Now we go back to tab number 2, and that's to run GDB and ask it to stop at the start kernel function. So here we see that GDB has put a breakpoint on start kernel, and then it has automatically continued the simulation. We're now left right at the start kernel function. Let's do a next GDB command. Now we go over the print k that we had just added, and so on. We can also just list the source code as normal. If you go back to the first terminal, we see that it is empty because the simulation is paused. So let's do a continue on GDB. And back on the first terminal, Linux kernel finishes booting, and GDB is just hanging. If we do a Ctrl C, for example, it will stop wherever the simulation had been running at the current instruction, here the idle function, then we can continue debugging as desired. So in summary, the Linux Kernel Module Cheat aims to be an extremely clean way to study systems programming and to make it very fun and easy to do. Thank you for watching and make sure to give it a try.